traffic volume on the streets has increased drastically in recent years, and with it, the volume of diesel engine exhaust particles. Modern diesel engines are high-tech aggregates, engine optimized to provide for minimal harmful emissions. The combustion process is vastly improved using computer modeling. Fuel is more thoroughly combusted than in earlier generations of diesel engines. The MAN Commercial Vehicle Engine Test Lab in Nuremberg for testing new engine design concepts. The lab technician runs a standardized program to simulate the engine function under real-world conditions, with acceleration, full capacity operation, and braking phases. During the 30-minute test run, part of the exhaust fumes are piped through a filter. The filter captures solid particles, including diesel soot. This contains metallic ash, which can clog conventional filters, eventually burning through and destroying them. Our research goal was a maintenance-free soot trap that continually regenerates the soot and does not clog up. What exactly does this diesel soot look like? This stainless steel holder contains minute copper grids, which trap the fine soot particles from the engine's exhaust fumes. The Fritz Haber Institute of the Max Planck Society in Berlin. In the Department of Inorganic Chemistry, diesel soot samples are examined. Invisible to the naked eye, an extremely thin, porous carbon film covers the tiny metal strands which catch the soot particles. Dr. Jens Oliver Müller at work. This high-resolution transmission electron microscope is one of the most powerful in the world. Soot particles concentrated around the edges of the pores of the carbon film. These are themselves made up of smaller subparticles. At the highest magnification, individual carbon atomic layers can be made out in the soot. The images held astonishing results for the researchers. We noticed differences between the emissions from modern diesel engines and the conventional kind of diesel exhaust. Its structure is highly irregular and contains many defects. A highly fullerenoid structure, unlike the usual graphite-like structure. But what does this mean for the chemical behavior of the diesel engine soot? Its chemical reactivity can be examined via infrared spectroscopy. The infrared spectrum shows the soot has already begun reacting with oxygen. So these exhaust emissions, unlike other types, should be easily combustible. A sample of diesel soot is heated in an oxygen flow inside an oven. It is continuously weighed with a highly sensitive scale. This diesel soot actually does turn out to be highly reactive. It begins to burn at comparatively low temperatures. Adding NO2, which can be produced in any diesel engine's exhaust, further lowers the combustion temperature. This enables us to build a soot trap. A so-called open particle filter was developed, based on the Max Planck Institute's research, the PMCAT. Casing and interior are made of non-corroding stainless steel. It is designed so the soot particles are caught in a fine metallic membrane. An open system that does not clog up with soot as conventional particle filters do. The trapped soot particles are burned with NO2, combusting into carbon dioxide with no additional heating required. The researchers are about to see whether or not the PM-CAT will live up to their high expectations in the engine lab. It does. The soot trap reduces diesel particle emissions by up to 90%. Once ready for serial production, the soot filter and catalytic converter fits easily inside the muffler. This allows it to be installed in existing vehicles as well. It is so light it has no impact on load capacity. The system was developed by chemists, physicists, and engineers. Under the name of PM-CAT, it has become standard in buses and trucks. The soot trap is a good example of how fundamental research can be implemented quickly and effectively in industrial applications.